Hello everyone. So today in this video I will be showing in your RAG application when you will use dot product and when you will have to use cosine similarity. So most of the cases whenever we are dealing with retrieval augmented generation, we need to actually search the similar items out of our vector embeddings, and in that case we need to actually use whether dot product or cosine similarity. So in this video I will break down like what are they actually means in any geometrical diagram or mathematical term, and I will also show you that when you will use dot product and when you will use cosine similarity. So let's get start this video. Here you can see we are comparing the dot product versus cosine similarity, and to visually demonstrate is why cosine similarity is often better metric for semantic relevance than dot product. I will show by how vector magnitude basically means the length of the vector can be misleading. So what are vector magnitude? For example, you have a vector which is a vector 3i plus 2j plus 2k, something like this. So how you calculate the vector magnitude? Square root of all of the individual numbers, like individual unit vectors square, and then you square root those and you get the vector magnitude. So here I will actually show you like in this 2D plot. Here is the x-axis and here is the y-axis, and here you can see we have a query vector which is 3, 3, and we have a document A vector which is 2, 2, and there is another vector which is document B which is 5, 1. So I have taken this example to make you understand more easily that how are these cosine similarity and dot product are being calculated. So here you can see document 1 is actually overlapped with the query. That means the angle between query and document A is basically 0. That means they are overlapping with each other. On the other hand, if you see the document B and the query, there is a angle between them. Let's say the angle is theta, right? So how you will calculate the cosine similarity score? Basically this is the formula here. So if I zoom in a little bit, cosine similarity equals to A dot B divided by both of their magnitude, right? Now let's see how the cosine similarity score are being calculated with document A and document B with respect to the query. So here if we calculate the cosine similarity of query and document A, which is basically 1. Why 1? Because the angle between them is 0. So that means cos 0 degree equals to 1. So that's why the cosine similarity score between these vectors are 1. On the other hand, if we take cosine similarity between query and document B, which is here, it's somewhere, for example, let's say 0.83. That means our query is more similar to document A rather than document B. This is how the cosine similarity works. And the main important is that cosine similarity only care about just one thing, which is the angle between the vectors. For example, you have two vectors and it just calculate the angle between them, and a smaller angle means the more similarity, which is in this case document A and query. Now let's go into the dot product, like how dot product actually means. So dot product actually considers both angle between two vectors and the length of the vectors. And this is where things actually go wrong. So the formula of this dot product is that A dot B, here you are taking all of the vectors and you are multiplying them and you are adding them together. So that means you are considering the length of the vectors as well as the angle of the vectors. So here it actually focuses on direction, not the length, which is word count. So the thing is that like here we have to use cosine similarity to find the most semantically relevant documents. So I have plotted these 3D visualization of document and query vectors. So I will go to the code part in a moment. So here you can see we have three documents. Document A, which is short and relevant. Document C, which is irrelevant. And on the other hand, document B, which is long and less focused. So if you take a look into the query vector, which is more aligned to our document A vector, that means the cosine similarity between document A and the query is smaller. That means the smaller the angle, which is greater the cosine similarity score. In that case, document A is the perfect alignment. So let's show them into the code part. So I have written a simple code snippet right there. So here is the dot product part, which is the dot product of two vectors A and B, which can be derived in two main ways, which is, for example, algebraic definition A dot B equals to this way, and the geometric definition, which is A dot B equals to AB cos theta. You guys already knows this. And A and B are basically the magnitudes, or you can say they're L2 norms. If you actually went to the machine learning concepts, L2 norms, where A and B are the vectors, and the theta is the basically angle between two vectors. On the other hand, the cosine similarity, which actually measures the cosine angle between two vectors, and which actually effectively judging their orientation irrespective to their magnitude. So it doesn't care about the magnitude of the vector, it just cares about the angle between two these vectors. So here you can see this is the formula, and here if you get 1, that means which is the exact direction. If you get cosine similarity score 0, that means they are perpendicular, which is orthogonal. So document A, document and the query are perpendicular, 90-degree angle. That means they are not similar. And that can be also negative. The vector points are in opposite direction, which is -1. So let's see this code example. Here I have imported NumPy scikit-learn. From scikit-learn I have imported TF IDF vectorizer, and from scikit-learn.matrices.pairwise I have imported the cosine similarity scores to calculate the cosine similarity. And the TF IDF vectorizer is basically vectorize our document. So here let's define our documents and the query. The query is basically the best deep learning framework. This is the query. And the document A, which is more relevant, as I shown in here. Here you can see document A, which is short and relevant. So PyTorch is the best and most popular deep learning framework. This is our document A. On the other hand, document B, which is very long, here you can see machine learning is a broad field. It includes many algorithms like linear regression, support vector machine, etc., etc. And finally, document C, which is irrelevant. There is no connection between document C and query, which is the history of Roman Empire. You can see there is no connection, and you can also see there is no connection between them. So let's vectorize our documents. So I have imported the object for vectorizer, and I have used norm equals to none. That means to preserve the raw vector magnitudes. And we have the vectorizer.feed transform. We passed the documents, which is a list of documents. Here you can see document A, document B, and document C. And we have also transformed the query vector so that we can measure the distance between two vectors or maybe calculate the cosine similarity score. So let's inspect the vectors and their magnitude. So I have used np dot linear alp dot norm function, which basically from numpy, which actually calculates the magnitude of the vectors. So here then I have calculated the dot product similarity. So dot product is basically simple. If you use np dot and you have used the query vector and the corpus vector, basically means the document vector, and you take the dot products out of it. And I have printed the query versus query versus the documents and their score as well. And here the result with dot product is basically the most similar document is here from np.argmax. So I have taken the maximum number which from this particular document score score list, and I have taken those that index of the maximum element and put the similar document here. And for the cosine similarity score, I have calculated the query vector with all the corpus vector. So if I show you, like if you see the vector magnitudes, document A has magnitude of 4.1260, document B has 16.6457, and document C has magnitude around 6. So if you calculate the dot product between all of the documents with the query, you see that document B has the highest dot product, right? Why highest? Because it calculates the magnitudes. On the other hand, you can see in the case of cosine similarity score, our document A has higher cosine similarity score. Why? Just because of that. Because our query vector and document A vector and the angle between them is lowest. That's why these are more aligned with the query apart from document C and document B. And here you can see the most similar document is A in terms of cosine similarity, and in terms of dot product the most similar is basically comes out of B. So this is the misleading part when it comes to your retrieval augmented generation. So if you want more relevant documents, you should use cosine similarity score, because dot product essentially actually consider about the angles and the magnitude of the vector. On the other hand, cosine similarity only care about their angle between them. So this is the comparison between dot product and similarity score, and when you should use cosine similarity score when you want most relevant documents. So yep, thank you.